Okay, hi everybody. Today I want to show you a machine that essentially plays my video games for me. So as a pretty busy college student, I don't have time to be able to play as much games as I did back when I was in high school or middle school. And so this machine is designed to essentially, you know, play the menial and like very repetitive tasks of a game for me, so that I can actually play the fun parts. So yeah, this is essentially what this machine does. And so I'll go ahead and explain what it does. So this is essentially going to play Pokemon for me. And so it's going to do a specific aspect of the game that I want it to do. And this aspect of the game is to locate shiny Pokemon. So as you can see on the right, there's kind of a dragon Pokemon. One's green and one's black. The black one is the shiny Pokemon, and it has a 1 in 4,096 chance of actually appearing, very low. And so, you know, what I want it to do is essentially to find this Pokemon. But usually to find a Pokemon like this, um, it's a series of incredibly repetitive tasks that you have to do over and over again. There's people on Twitch, if you go up and look it up right now, there's people on Twitch who stream for hours on end doing the same exact button inputs just to find these Pokemon running back and forth in the grass. And I wanted to develop an approach to where I wouldn't have to spend as much time doing that. And so what I wanted to do um, was specifically focus on the legendary Pokemon. Because they were stationary, um, and because you can only get one per game, if I got a shiny of these, that would be actually very valuable, and I wanted one of these. So in order to do that, I had to determine how to actually detect whether Pokemon was shiny. Now, brainstorming this, I was thinking of using an OpenCV to check the pixels, um, or essentially the color of a Pokemon. That essentially became a lot more complex than I thought it would. So I settled for a different solution. So essentially, the bottom screen will dim when a Pokemon is encountered. Now, back to this first screen right here. Um, as you can see on the right hand GIF right there, that Pokemon has an extra sparkle animation. Shiny Pokemon have this extra sparkle animation that is augmented to its actual encounter. And so what this does is it actually increases the time that the screen is dimmed by. And so by using this data with in conjunction a photoresistor, we can actually detect the amount of time that it takes for the screen to dim. If the screen dims past a certain threshold, we can actually determine whether it's a shiny or not. And yeah, that's just essentially repeating what I said. And this is kind of the schematic of the entire program. But essentially, the gist of it is that that photoresistor is essentially taking inputs to determine whether or not that threshold passes or not. If it doesn't pass the threshold, what it'll do is it'll reset the system until it goes ahead and finds a shiny Pokemon. And so here's just the video of it actually working. Um, Obviously, this process takes a ridiculous amount of time. So I did cut in the middle of the video in order to show the, the initial actually encountering the Pokemon and the result of finding it.
So as you can see right here, this is how our shiny hunter works. So here's our photoresistor right here. It reads how long the bottom screen is dimmed, and if it's shiny, because that shiny sparkle plays, the dim on the bottom screen will actually be a lot longer. So then it'll tell that information to my program, and it'll detect when it actually is shiny. And it uses these servos to command the buttons. You're probably wondering what the heck these rubber bands and that dime is for. Simply, that's just for the soft reset. You need to hold down L, R, and start select. So I just have it always holding down L and R with those rubber bands. And with the dime, Because unfortunately Ultra Sun and Moon, the Pokemon games I'm playing, do not take movement inputs from the D-pad. I need to stick a dime up the control stick and have the player move. And so yeah. So here's the result. As you can see earlier, I was hunting for that Regirock, and now it's shiny. And as you can see right here, the amount of time that it spent was about 4,581 seconds and about 154 encounters. So yeah, there you go.
So yeah, as you can see right there, sorry for the bad video rotation at the end, but essentially that program will essentially keep moving the servo motors where I place them in order to reset the program. And if it's shiny, what it'll actually do is it'll completely halt the program. And when I come back and I see that it's shiny, I am delightfully surprised, and I go ahead and catch the Pokemon. And so,
As you can see right
sorry,
here,
I don't want to play that again. And so the results actually of doing this for about 2 weeks is that I captured 15 shinies. Yeah, and it was approximately 167 hours of constant hunting. I ran this program into the night, and my goodness, yeah, it was crazy, but I I woke up sometimes to a surprise. Sometimes the program would take longer, and I'd come back in the middle of the day. I'd see a shiny Pokemon. It was great. And what I did during that time was I spent time with friends and family, socially distanced, of course. And I do want to go ahead and actually talk about some of the flaws I encountered while doing this project. Um, Oh, I also want to show one more thing. These Pokemon are not just for show. You can actually sell them on eBay. There's kind of this like black market. Um, I think you know I would hope that each of these Pokemon costs around a little bit $5 ish, and so yeah. But yeah, I do want to get to the flaws here. And so one of those flaws was that the mechanical components were very clunky since I used Legos and rubber bands. Hopefully, when I get back on campus, I would like to, start tinkering around with some 3D modeling and printing, so I can actually make the actual hardware structure a little bit more cohesive. Sometimes, unfortunately, there will be false shiny reads. Um, and this isn't actually an issue with, I would say, any of my programming. I did a lot of testing on this. It's actually a problem with the game itself lagging. The Pokemon game itself um, is not very well optimized, and um, yeah, it's not very well optimized, and it is very prone to lags. It really tries to go ahead and take advantage of most of the 3DS's features, so there will be some lag sometimes, and that ends up making the photoresistor read more than it should, and sometimes there'll be a false shiny read. Um, yeah, sometimes the game lagging also um, can also have the servos press buttons when they're not supposed to, because of the weirdness with the weird photoresist readings. But all in all, these are quite minor bugs, to be honest. I don't encounter them relatively frequently. And so, yeah. Improvements. I definitely would not like to use Legos. um, I would also like to be able to use OpenCV, which is essentially just a open library that, in conjunction with the web camera, can actually detect certain like colors or pixel values. Um, and I would like to incorporate this with Arduino to do that double check, just in case the game lags. That would be really nice. Yeah, again, use 3D printed hardware. And one last thing would be a color sensor. I would like this to work with multiple games, and so in some Pokemon games, the screen doesn't actually dim during the encounter time, but what I can actually measure is the color of the UI because that changes, and so I can actually detect how much time it will take for the UI to actually appear. And so yeah, these are just some of the resources I used while making this project. I actually got the idea from the hardware from that last video, but the general idea, I actually changed the hardware quite a bit when it came to developing this on more current Pokemon game. Um, yeah, and I also wrote all the code myself. You know, I got a little help from my electrical engineering class, just learning how the Millis function worked and stuff like that. But basically, I think the main thing I really learned from doing this project was that I really enjoyed kind of the signal image processing side of this because I was really kind of astonished by the fact that I didn't have to actually look at whether the Pokemon was shiny or not. I could determine that from how the screen was dimmed. Um, Essentially, kind of simplifying the intake a computer gets in order to interpret that and make valuable decisions from that. It's a very powerful tool, and it's something that I want to get more into, especially with things like OpenCV. I want to be able to kind of be able to use OpenCV and MATLAB in conjunction to simplify images and kind of work with AI in the future. And so, yeah, thank you all for sticking around. And yeah, that's the end of my program.